Hello everyone, this is Pramod. I'm currently a student from IIT Guwahati in CSC department, and this is my first video on YouTube. I'm super excited to start this video. I'm bringing my way of explanation to this problem to you guys. I hope it really helps, especially for those who could not solve this problem. And one more help I can get from this is that my intern seasons are gonna start next month, so I can check the way I'm explaining the solution to any problem which I have to do in the interview. So in this way, it really helps to me. And yeah, that's it. Let's start the problem. Yeah, this problem is from AtCoder Beginner Contest 255, which was held on 11th of June 2022, and it's the D problem plus or minus one operation. Okay, yeah, let's read the problem statement. Uh, you are given a sequence of length n, a1, a2, an. Uh, the following action on the sequence is called an operation. You have to choose an integer I from 1 to n, and you have you can actually do any of the two operations. Okay, you can increment ai by 1 or decrement ai by 1. Okay, and you are given few queries. The ith query is like you have to perform zero or more operations to change every element of a to that x. All right, so you need to find the minimum number of operations. All right, you are given n and q bounds. All right, let's see the test case. Okay, so the n is the number of elements in the array, and q queries are given. Okay, and this is the input array, and first query is 5, second query is 20, third query is 0. Okay, so this array is given. Now you have to change every element of this array to xi. All right, let's solve the first query. Okay, to 5, so how many operations are required to change 6 to 5? Okay, how many operations? Exactly one. And you have to change 5 to you have to change 11 to 5. 6 operations are required. You have to change 2 to 5. All right, so you have to increment by 3 times, so 3 operations are required. If it is exactly 5, no operations are required, so total we require 10 operations. All right, this is looking wise, it's you might think it's a very straightforward problem, but I guess you got TLE or something. All right, if you got the TLA, then you are doing like in each query you are traversing the whole array, which will give you nq of nq time complexity, which is 2 into 10 to the power of 5 whole square, which is 4 into 10 to the power of 10. So for 4 into 10 to the power of 10, you can't do of n, uh, you can't do any problem in O of n, so you have to do it in O of 1 or O of log n. All right, so let's see how this problem can be done. All right, so let's take the input array, one example array. All right, 6 11 11 2 5 5. All right, just a second. 6 11 11 6 11 2 5 5. All right, 2 5 5. All right, so what could be the solution? See, the solution is like just first sort the array, alright? Sort the array, which will give 2, 5, 5, 6, 11. Okay, just sort it first. Sorry, please. Sort it. Alright, now let's divide it into cases. Alright, case 1, whatever x that was given, if x is greater than highest element. Alright, see, this is an example array. Let's take general array. Okay, it's like a1, a2, a3, so on up till an. Alright, it's like a1, a2, a3, so on up till an. Alright, now if x is greater than, it is sorted array. Okay, it is sorted array. Now if x is greater than an, that means x lies somewhere over here. Okay, now what will be the number of operations required? See, on calculating, just see. Okay, let the distance between an and x be alpha. Okay, now for a1 to change it to x, you need to do exactly x minus a1 operations, right? To change at to x, you need to do exactly x minus a2 operations, right? Plus so on up till x minus an operations. Alright, this is the number of operations required. But you can also write it in this way, that we have returned this expression in terms of x, right? Now we can also write in terms of a1, a2, and so on. Okay, now this x minus a1 can be written as an minus a1 plus alpha, right? Plus x minus a2 can be written as an minus a2 plus alpha. Alright, got it. Now so on similarly up till where an minus an plus alpha. So it really sucks. An minus an plus alpha. Now what will this expression reduce to? It is like an occurring n times. Okay, now an occurring n times, which is equivalent to nan plus alpha occurring n times n alpha minus a1 plus a2 plus so on n sigma a. Alright, now, alright, got it. So if x is rightmost, I mean it is greater than the larger element, then the number of operations are this much. Alright, now what is this alpha? Where alpha is simply x minus an. Got it? So you can directly, instead of traversing the whole array, you can write in this way, right? So we'll take off one time. Not off n. Alright. Now, if let's see the case 2. Alright. Case 2 is if x is smaller than smaller element in the array. Alright, that means here it is A1, here it is A2, so on up till AN, the X lies somewhere over here. Alright, now what will be the number of operations required? It's like, first let's write the expression in terms of X. Okay, now number of operations required to change A1 to X is simply A1 minus X, plus number of operations required to change A2 to X is simply A2 minus X, plus so on up till for AN to X it is simply AN minus X. Alright, let's say this distance is alpha now. Alright, now we can also write this expression like A1 minus X, right? So you can also write like A2 minus, it's like sorry, just a second, A1 minus A1. Alright, A1 minus A1 plus alpha. Alright, A1 minus X can be written as like that. Now A2 minus X, this distance can be written as A2 minus A1 plus alpha. Similarly, AN can be written as AN minus A1 plus alpha. Alright, what is this expression reduced to? It is simply A1 plus A2 plus so on, so sigma A. Alright, plus how many times A1 is occurring? N times, minus N A1 plus how many times alpha is occurring? It is minus N A1 plus N alpha. Got it? So you have seen the two cases. One is leftmost, one is rightmost. Now let's check for the middle one. Alright, that is X lies somewhere between A1 and AN. Alright, X lies somewhere between A1 and AN. Let's say A3, let's say A4. Alright, now what you have to do is to find the number of operations. Okay, you can treat it like this, right? See, it's like number of operations required in this array, number of operations required for this, right? That will add up to total number of operations, right? Now for this you apply the case 1, for this you apply case 2, this will add up to total answer. Alright, now but there is some, it's like you have to implement the code in a little bit tricky manner. Now uh, you can directly write the code for case 1 and case 2, but the case 3 it's like little bit trickier. So how will you find where X lies? So you remembered one thing, that is lower bound in any vector. It simply says that lower bound of any element X in that vector simply says that uh, it will traverse from left to right. Okay, it will just returns iterator which is pointing to element greater than or equal to X. Alright, greater than or equal to X. For example, let's say X equal to 10, A1 is 5, A2 is 8, A3 is 11, A4 is 13. So lower bound of 10 will return an iterator that is pointing to an element which is greater than or equal to x. Here in this case it is 11. Alright. If it is 10, then it will point to that. And also it will point to the first occurrence of it. Okay. Got it? Now for x, so just find the lower bound of this array. Find the lower bound of this array. Okay. That will return an iterator that is pointing to a4 here in this case. Alright. So that will return an iterator pointing to this case, and it's just an implementation thing now. Right. I guess I've explained it better. Is there anything left? Yep. I think nothing is left. Cool, I guess. Yeah, got it. So if an IT is this, okay. Now, how many number of elements are there to the left of this A4? I mean, before X, how many elements are occurring that we need? Okay, how many elements are occurring? It is simply IT. How many elements are occurring? It is simply n minus IT. And while applying case 1, sorry, it's case 1. While applying case 1, see, the case 1 is like n into an, number of elements into the last element. All right, last element is a3, and number of elements is it, and the last element is a3, and the last element can be found out like that. Last element is like, if you know the it, so the last element will be a of it minus 1. Got it? Now n into alpha. Now you know this term. Now n into alpha, n is already it, we know, and alpha is x minus an. You know the value of x, and an is simply what? An last element is already a of it minus 1. You know this, so x minus a of it minus 1 you will do. Alright, and sigma a is sum of all these elements. Now you don't write again for loop inside that while loop, which will lead to taily. Okay, so what will you do is pre-calculate the sum before only. How will you do that? If initially it is arrays a1, a2, a3, a4, something like that. Okay, now pre-calculate the array, pre-calculate the sum. Let's create a new array, that is prefix array, which is of size n. Okay, let's say there are 5 elements in the array. Okay, prefix of n. Let's create this array. Now simply prefix of uh, I is like sum from index 0 to index I. Alright, it's like a of 2 is like this sum. Just calculate it here. Okay, it's like a1, a2, a3, a4, a5. Prefix of 0, prefix array is like a1, and simply a1 plus a2, a1 plus a2 plus a3, a1 plus a2 plus a3 plus a4 plus a4. Alright, this is the prefix array, which is really helpful because you need not calculate the sum of those elements again. Alright, if you want to know this a1 plus a2 plus a3, simply write prefix of that index. That index is, you know, that it minus 1. Prefix of it minus 1, which will give you this sum. Alright, now to calculate this sum, just simply write, to calculate the rightmost sum, simply like prefix of n minus 1, which will be the total sum, minus prefix of it minus 1, which is the leftmost sum. So that will give you this sum, because this sum is also required in case 2, right? And you know the alpha similar to case 1, and in the A1 also it is simply A of it. Got it? Yeah, that's it. That's the explanation of this code. Now let's see the code. Right? What I have done is, first initially we have to sort this array. Okay. Now I have created that prefix sum array as a vector. Okay. So I have calculated the prefix sum array like this. That prefix of I is simply the previous up till sum plus that current element sum. Okay. Which will, you know how to do this. Now we are checking each query. Okay. Now we are seeing this is a x greater than or equal to a of n minus 1. That is, which case is it? X greater than or equal to a of n minus 1, that is the rightmost element. So we are checking case 1 first. Okay. So case 1 may, what is the answer? Answer is simply n a n plus n alpha minus sigma a. All right. N into alpha. What is this? X minus a of n minus 1. It is alpha term, right? It is alpha term. Got it? N into absolute of x minus a of n minus 1. This is alpha term, and n into an, and we are calculating prefix sum. All right. Now, if x lies to the leftmost, you can write this equation similarly. All right. This is the case 2-1. All right. Case 2-1. You can write it. Now, if x lies somewhere in the middle, now just calculate the lower bound of x in the array. All right. Now we are taking two different parts. Okay, the leftmost part and the rightmost part, and this x1 is for the rightmost part. Now in the rightmost part, total n minus it elements are there. All right, and total out of what is n minus it elements are there. All right, n minus, where is that? N minus it elements are there. I need to start uh, need to start from, this is if this is like which case is it? Case 1, case 2, right? So sum of elements minus n into a1. This is the first element. First element is like a of it. All right. First element is like a of it. All right. So you have multiplied this and number of elements into the alpha term. This is alpha term, and you have calculated the prefix sum. All right. It is direct substitution in that thing. All right, just sum those answers and return that answer. Yeah, this is the explanation. This is my explanation, my way of explanation to this problem. Hope it really helps, especially for those who couldn't solve this problem. And please do share the feedback uh, in the comment section. Thank you so much, and see you in the next one. Bye bye.